Good morning to all of you and welcome on behalf of Plano Public Library. We are happy to have you with us today. My name is Kristen and I am responsible for partnerships, community partnerships, and I'm very happy to have with us today Kyle Aruda. Kyle is an engineer, a mechanical engineer. He is a mechanical engineer who has worked as a machine designer, a mold designer, a tool designer. And for the past 20 years, he has worked for Siemens Digital Industry Software. He's currently a portfolio development executive who helps customers start with why so that they can be more creative and more innovative. Kyle, we're very happy to have you with us today. Thank you so much for your time, and let's get started.
All right. Thank you very much, and it's a pleasure being here, and I thank everyone for joining us. I'm going to go ahead and get my screen going. So and also, there we go. So share. So everybody should be seeing my screen, hopefully. Popping off of the page is the title of our session here today, and it is talking about 3D design or 3D CAD, and it pretty much implies what it is. And if you've ever thought about how something was designed, everything around us today is we live in a 3D world, and virtually everything that you purchase, that you see, that you interact with is designed in 3D first, and that's how you get an idea onto your page. But a lot of people ask me a question. It's like, well, I've heard 2D, I've heard 3D. What's really the difference, other than the number 2 and the number 3? And this is how I explain it. And so when you think of 2D, 2 dimensions, if you remember back in your math days, some of you may be coming into this into math based on your age. You always did a plot, right, where you had an x-axis and you had a y-axis. Well, that is 2D, right? It's 2 dimensions. You're drawing things or you're seeing things in 2 dimensions. And so you have an x and a y. But to make that 3rd dimension is where you actually add one more axis, and we call that the z-axis. And we learn this through math, all through math, depending upon how far you go in your math. But you also understand this from an artistic standpoint. Whenever you draw something in perspective, you're drawing something that makes it look like 3D through that 3rd dimension. And to actually understand this a little bit more, I'll hopefully relate it to something that everybody knows, and that's movies. We all go to the movies. We may not have gone to the movies here lately, but we hope to get back into going to see the big screen. And a lot of times, nowadays, whenever you go watch a movie, they're asking you, do you want to see the movie in 3D? Well, as you can see here, it's a 2D look at the Spy Kids movie. But if you go in and you actually purchase a 3D movie and you put on those glasses, you actually get that 3rd dimension. It's coming out at you. And that's what really 3D is all about, right? And that's how, as we'll learn today, how you can actually design. And there's advantages to doing that. So before we get going into the presentation, I just want to ask a real quick question. Because this is a term that I'm going to be using a lot in this presentation. And it's basically, we're asking the question for this poll is, what does CAD stand for? It is an acronym, CAD. So it has 3 words that is mentioned for that. So we'll sit there and get everybody to see if you understand what that is. And it looks like most people are coming in there. Excellent. Getting most everybody. 9 out of 12. A couple more people. All right. So the majority of you, 64% of you, are correct. It does stand for computer-aided design. Now, I'm going to date myself a little bit. And I've been in this industry for 20 years, but I'm 50 years old. So whenever I was a engineer out in the real world, when I say I have a real job, back when I had a real job, I learned, whenever I went through college, I learned how to design something in 2D on the drawing board itself. And then we got into the computer aided design, where we could draw lines and arcs and things like that on the computer, which helps us out a lot to understand what's that there. And so just to give you a brief history, if you look, the history of CAD started back in the 1950s, right? And from Dr. Patrick Hanratty. And it's evolved through the ages, and you can see Ford back in 1967 and McDonnell Douglas 1966. So you can think about an airplane or a car, being able to design that in 3D to understand the weight of the vehicle, the weight of the airplane, those type of things. And those are things that we'll talk about today in there. And so there's been a lot of history with computer aided design, and there's been a lot of advancements over the years and stuff. And there's some really exciting stuff coming that's here today, and actually seen in the future what is coming with the ability with CAD, and we'll talk about those in a minute. So let me ask this question. Now that you know what CAD is, and most of you understood what CAD stood for, do you know somebody who uses 3D CAD? You may be that person who who uses 3D CAD systems. So I kind of want to understand where does everybody fit in using a 3D CAD system. So if we could pop that poll up and ask the folks who's been using CAD. Did that come up? There it is. Okay. So do you know somebody? And again, that somebody could be yourself. And so I'm just trying to get an understanding of where everybody's at. All right, so it's looking like 50-50, and that's about typical whenever we ask this question and everything. So it's about a 50-50, and that's fine. And that's good to know, because a lot of you are going to understand what it is that we're going through today, but a lot of you are going to learn what it is. And so I like to ask this question. This is a rhetorical question. Don't need to answer this one, but I want you to think in your mind for a moment. Who do you think uses 3D CAD? I kind of gave you a little preview there in the beginning of my intro of who uses 3D CAD, and again I can ask the question. And again, given the situation that we're in these days, if you've ever been to a hospital, all right, everything that's in a hospital, or you've gone to the dentist, dentists are now opening back up. We get to go clean our teeth, dentist, or if you've had any kind of implants, okay, these are medical companies use 3D CAD all the time, especially the advancements of implants, a knee replacement, or some kind of socket or a shoulder replacement. Those are actually, you can take an x-ray. This is amazing. You can take an x-ray and actually turn that x-ray into 3D and actually print out the replacement that's going to go inside your body, right? Another way of looking this is vehicles that are, let's say, boats and ships, those type of things. And not only the outside of the boat, but also the inside of the boat, companies use 3D CAD to design all this so that they can get good fit and function. And again, also look at weight. Now, you may not have ever thought about this either, but once we get back to traveling, you may be traveling, but the next time you go into a hotel room, all the furniture that's in that hotel room is designed in 3D. Your appliances that you have in your kitchen are designed in 3D, right? We can't, got to have our coffee in the morning. And then things that you wear, jewelry, and things like that. And if you're a kid and you've got a Razor scooter, I love the people at Razor. They're one of my customers, and it's fun and it's interesting to watch them design and come up with different ideas. Or, nowadays when you try to go buy a bicycle, good luck trying to find one. Everybody's riding bicycles. All these type of things that we use on a daily basis, somebody actually designs in 3D. And we all hopefully have probably watched what's been going on with SpaceX and NASA and taking astronauts back up into space. Their SpaceX uses 3D CAD to be able to design all that. They need to understand, how much weight is in something, how much thrust and everything else that needs to go along with that. Of course, airplanes, cars, and other type of vehicles. So these are things that, everything around you, people are using 3D CAD to make their designs. And they're able to make it to designs to make them safer. We'll talk about that as well. And take ideas from customers and stuff. So I want to ask one other question in there is, now that we understand what 3D CAD is, and some of you have know somebody who does it, what is your experience? Have you actually experienced using 3D CAD? And so I'm just asking it, I've never used it. How long have you used it for? And that type of thing. All right, beautiful. So like most of you have never used 3D CAD, that's great. And hopefully, by the end of this presentation, I will give you an opportunity to where you can use it and stuff. And so we will get to that at the end of the presentation today. And so I want to ask one more question, right? And that's, have you ever had an idea before, but you just didn't know how to create it? Okay. And you'll see why I asked this question later on in our presentation. But that's the one thing, especially nowadays, most people now have access or can have access to a 3D CAD system, but they also have access to a product that will enable them to actually make it. And you probably have heard of 3D printers. We'll get into that and how you can go do it. Okay, perfect. So we'll give you the ability to be able to use a 3D CAD system. We'll talk about that and how you can do it, and also how to get access through a 3D printer. And so, like Kristen was saying in the beginning in my description there, I really like to help people understand why. Why are you doing what you're doing? Why is it that we make things the way we make them? Or why am I coming up with this kind of idea? Well, I asked the question, well, why 3D? Right? Because I like to start everything with why. And it helps everybody understand. And so really the first why, 3D, is very, very simple. It helps you see things in a realistic way. It helps you create things very easily. And it also helps you create things very quickly. More so than it would have been in just 2D or you just sitting there, trying to whittle something or put something together. 3D CAD and software enables you to do that. So I want to take a look at a video here. I'm going to talk over this video, but what this video is going to do is it's going to help you understand how you can get started with an idea and how you can make it look realistic. And with everything, we do start out with a 2D. We add that third dimension to make that 3D. But you have the ability then to say, okay, what are some of the parameters? What are some of the things that I need to make sure what the size of this is going to be? And to be able to click and drag and pull to be able to get that shape the way you want it, and then be able to put it together. It's just like putting together Legos, right? You're able to snap things together, modify them, putting things together. Everybody understands Legos, right? Well, that's what you're doing. You're building and designing a Lego. It's not a block, but it's something that has different shapes to it. That's what 3D CAD allows you to do, is to build your Legos and to snap them together into something. And as we saw there towards the end, you need to be able to understand, if you can't make it, you have to then possibly give it to somebody to make, and that's through a 2D drawing. It's funny, I have been in this industry for over 20 years, and 20 years ago, people were saying, drawings are going to go away. Drawings are still here today. And that's an easy way to communicate. But there are other ways of communicating, and we'll talk about that. So it's very simple to get your idea onto a piece of paper. And I know that video was kind of quick, but I just wanted to give you an idea to say, hey, here's how you can start it. It's almost like starting out with a napkin, right? You sketch out your idea on the piece of napkin, you add that third dimension, and you're able to see it. And as you build multiple ones, you bring them together, snap them together in what we call an assembly. And you can bring that live, right? And as you saw, there was some things to make it look like a real material, whether it be plastic, steel, wood, or that type of thing. In my next example, I have my colleague Doug, and Doug, created a video for us. And what Doug is going to do is he's going to take you through the process of looking at it from an easy standpoint. How easy is it to go and make changes to things? Because with any idea, you're always improving on your idea, and CAD will help you make those changes, right? So let's hear from Doug on how you can, once you get your idea, how easy it is to go make some changes. So let's take a listen for Doug.
I want to take a few minutes and show you some of the advantages of using solid edge with synchronous technology. Here we have a case where we have a pulley system, and I want to take this pulley and I want to make it 20 millimeters wider to accept a wider belt. So how you do this in solid edge is I would go in here and I would edit that part. You can see there it is in the context of the assembly. I'll go ahead and hide that. You can see that it has a seat for a bearing on either side. You can see there's a hole through the center for a shaft. A pattern of holes and a pattern of teeth around there. So let's make it 20 millimeters wider. So if I look over here on the left in the feature tree, you can see that this is an ordered model, meaning this is history based, one feature on top of another feature. Being that I was not the person who designed this pulley, I have to first figure out what feature I need to edit to actually make this pulley wider. I can see that those faces highlight on the very first protrusion. So I'm going to go ahead and edit that feature. You can see what it does is it rolls the model back, and this is how history-based modeling works. It rolls the model back to that particular feature. I can see there's a dimension here for the width. I'm going to change that by 20 millimeters, and then I'm going to click Finish. And I can see that now I have a problem. You can see some exclamation marks next to some features that have failed. There's been some dependencies that have been developed that we did not even anticipate. Whoever designed this part did not anticipate me making it 20 millimeters wider, and so those feature dependencies are causing me problems. And so now I've got to figure out how to fix the model. And this is the problem with history-based modeling. Very, very common problem. So I'm going to go ahead and I'm going to undo that. I'm going to go back to the original state, and I'm going to move this to the new technology that we have in Solid Edge called Synchronous technology. So I move all of those features up to Synchronous. Now that they're in Synchronous, I no longer have those dependencies between features. Feature 1 could be clear at the bottom of the tree because, again, there is no dependency. So how you modify a part in Synchronous technology is you select what you want to change. I know that I want this front face to move. I want the inside of the lip to also move with it. So I'll select that. I also want this hub to get wider. I want this part to get wider, and of course I want the seat for the bearing to move with any change that we make to the width. So I simply select those things, I select the arrow in the direction that I want to move. You can see that as I begin to drag and make this wider, that it's staying symmetric. Because of the proprietary Design Intent Manager in the upper right corner of the screen, it's maintaining symmetry for me about the base coordinate system, which is great. So all I really have to move is 10 millimeters to get 20 millimeters wider. So I no longer had to worry about what feature to edit, what sketch to edit. All I have to do is select the faces that I want to change and make the modification. Very, very quick and easy with Synchronous technology. Let's go back to our assembly. And of course we can see that we have a little bit of a problem in that all of the parts are interfering with that wider pulley. It needs to accommodate the wider pulley with all of the other parts. So I'm going to go ahead and I'm going to hide that pulley to start with. And another beautiful thing about synchronous technology is we have an option to actually select faces of parts at the assembly level. So in this case, I'm going to come in here and I know that I need this to get wider. I also need the bottom sheet metal part to get wider. Notice I'm only selecting one face because it is sheet metal, has a common thickness. The bearing moved correctly because it is seated inside of the pulley with an assembly relationship. However, the spacer needs to get shorter for the wider pulley, and the cutout in this girder needs to get wider. Now I'm only going to select one face because there is a coplanar face directly above it. And one of the things that it's looking for with the design intent relationships is coplanar. So it's going to find that for me. So notice I'm at the assembly level. I've selected faces on multiple parts at the assembly level, and I can click on that arrow just like I did in the pulley and begin to drag to make it wider. And because all those parts are symmetric, that's being maintained for me. And again, I only have to move 10 millimeters. So if I turn on my pulley, you can see that everything is great. We have the clearances that we need. So you can go into the parts and make changes if they are in fact synchronous parts. You can select faces directly from the assembly level and begin to modify those at the assembly level to change them in the part. Notice that the top sheet metal part is not as wide as the bottom, but I want them to be the same. Well, I don't want to have to measure how wide those are. So we have this option for face relationships at the assembly level. I'm going to pick coplanar. We even have a little video that shows you what that means. I'm going to click on coplanar. I'm going to select one face of the sheet metal part. It recognizes it's sheet metal. I'm going to say I want that all to come out to be coplanar with this part. And now they're the same width and I didn't have to even do any measuring. So there you've seen some of the beauty of synchronous technology, in that you can modify parts without having to worry about history, and you can modify parts at the assembly level at the same time.
So reason why I wanted to show you that is to show you what 3D CAD enables you to do. And the product that I represent is what Doug was talking about, is Solid Edge. And we have a unique way of doing this. And he showed you some things. If you model things in what we call a traditional way of modeling, you run into some issues. But we've built the technology in our 3D CAD software to overcome those, and it is called synchronous technology. And as you're able to see, you're able to just pick a few faces and be able to change them very easily and very quickly. And that's what 3D CAD enables you to bring. Now, he also talked about examples of 3D products. Sorry, my image got in the way of the word there. But I wanted to give you an example of what sheet metal is, because 20 years ago, I was a machine designer and stuff, and I had to deal with sheet metal. And it is very unique. But as you can see, refrigerators, dishwashers, AC units all use sheet metal. But even toys, as you can see here, use sheet metal as well. So again, everything around us is dealing with that. And so to show you, how you can even do this. Now think about sheet metal as being cardboard. Have you ever, taken apart a cardboard box and cut it into something, and then you folded it, you added creases to it and everything to make a different shape? That's really what sheet metal is. And back in the day, before 3D sheet metal came out, that's how people actually designed some things in sheet metal, was to use cardboard. But you have the ability now to do this with 3D CAD. And I'm just showing you the art of the possibility. It's not just a cube or a square or a block of metal or a block of wood. You have something that understands that it's a certain thickness, right? And there's different ways, because whenever not that all of you will be manufacturing sheet metal, but there are certain design and manufacturing rules that have to take place when it does come to sheet metal. And here I just wanted to show, again, what the art of the possibility is with 3D CAD, and that, think about, hopefully whenever you leave this and you go around and you look at your house, you'll be able to see some things that are made from sheet metal, and how quickly it is, or how easy it is for someone to actually design that, or somebody did take the time to design that and things. And so I just wanted to share with you some of these other things that you can do with that. And then going into our next, what I call why 3D, is you always heard a picture is worth 1,000 words. Well, I think with 3D CAD, not only can you make an image, but you can also make a movie, and that will give you the advantage of even more 1,000 words. And so Doug is going to walk you through how you can, once you have your design, how you can go and actually share that and make it look real through rendering and animation. If I can hit play, that'll be good.
Solid Edge is a great tool for designing a final product, but did you know it is also a great tool for marketing your product? This marketing could include introducing your product to the public, or internally within the company to get buy-in on a new design idea. Using Solid Edge's assembly constraints and motor functionality, you can show management how the internal mechanism operates under the cover. You may also need to show those in manufacturing how the product is assembled and show all the components that make up your new design. Rather than just show a single exploded drawing, it will be much more appealing and generate more excitement to actually see the virtual product explode and animate live on the screen, or share it as a movie saved from the animation environment. Solid Edge gives you simulation capabilities where you can virtually test your designs. Here's a video output from a stress analysis testing for strength. This is great for internal marketing, but also may look great on a website, for example, as immediately it's an impressive way to show your products are well designed and validated. Realistic rendering images are always a good tool to use in communicating a new design internally or to the public. The beauty of this is that you can generate realistic looking photo quality images before you ever cut the first piece of material to manufacture your product. Solid Edge provides a one-click export or update to KeyShot's best-in-class rendering. KeyShot makes it very easy to change materials, lighting, and environments by simply dragging and dropping from a huge library of optional materials, colors, lighting schemes, and backgrounds. And best of all, KeyShot is included with Solid Edge. KeyShot enables you to change the environment by tweaking its settings to your liking. KeyShot also offers you the ability to use your own custom image for the background to place your virtual product in a realistic environment. In this case, the razor can be rendered to appear as though it is sitting in a stack of towels. Check out these other awesome images of products designed in Solid Edge and rendered in KeyShot. To gauge a wider audience's opinion, YouTube is a great tool. In Solid Edge, you have the ability to record and upload directly from CAD. The video could be a screen recording with a voiceover talking about product detail, or a completed animation like the one we created previously. Solid Edge offers a perfect solution for sharing designs with its mobile viewing app. The best part is that it is easy to use, robust, requires no CAD license, and like everything tablet, a great user experience, which then gets reflected in your products. Within the app, you can pan, zoom, and rotate the model around to see it from any angle. You can also interrogate the design by hiding the external parts to see inside the assembly. The app also enables you to create screenshots at any time that you could then attach to a message or email, or post to social media for fast and easy collaboration. Solid Edge's mobile viewing app is available for both iOS and Android devices. Imagine being able to share your ideas by tablet or by simply using your smartphone. You no longer have to be a CAD expert to share your ideas within your company or with the world. So as you can clearly see, Solid Edge is not only a great tool for designing products for manufacturing, but it is also an awesome tool for reusing that design data for selling and marketing virtual products. Solid Edge.
So you can see, taking, once you design something, you really want to make it look real and you want to animate it, right? And that's easy to do with the CAD system, okay? Now, this next video is just something I threw in there just to show you the fun that you can actually have with, with 3D CAD. And let's see if we get going, get the right one. There we go. Now this one's got some music, but I'll talk over it. So this was actually done by one of my coworkers, and it's putting together this piece that you see here. And this is all made out of metal. But we wanted to understand the manufacturing process, and this is through a welding machine. And so it's actually going to animate and show you what it takes for a robot to go take the part, put it on the machine, and actually do a weld. And this was all designed using the 3D CAD, in this case Solid Edge. But here it's actually showing a manufacturing process. And again, it's just, there's multiple things that you can do with 3D CAD. Your imagination is really endless of how you can do this, but it also shows off the animation power and capabilities that you have with a 3D CAD system. And so if you can think it, the 3D CAD system, can do it and give you the ability to do it. And I think it's really cool because you can program robots, of how they need to do things alongside of here. And that's just a possibility. So I just wanted to share that with you because I thought it was a fun little video.
Solid Edge simulation offers a fully integrated experience.
So before I go to the next one, I'll click through that quickly. You saw a little bit through Doug's video, simulation. Now, simulation is very, very important in the world because think about safety. People don't want things to break, right? SpaceX, they don't want their vehicle to break. So they have to go through a lot of simulation to understand how something is going to break. And that's another aspect of what 3D CAD brings to you, is that once you design something, you can actually put forces on it. You can put gravity on it. And you can see, is this thing going to break? Is it going to be safe for somebody to use? And so that's what Craig is going to go through for us here for a little bit to show you that.
Providing options to simulate models for static studies such as stress, thermal, buckling, and vibration, and even fluid flow studies such as internal and external flows of materials to simulate things such as fans being used to cool electronic components. No matter what type of simulation study needing to be run, Solid Edge provides consistent workflows throughout. Simply define the forces and other loads acting on the parts, set the fixed ends and any additional constraints, and if working with an assembly, define how the parts fit together with connectors, and we're ready to go. Once complete, a wide range of results can be viewed and even animated. These animations, as well as a comprehensive automated report generation tool, ensure that all of the important information is collected for use with design reviews and marketing materials. Still want more? Solid Edge can even automate finding the optimum design for desired results. If you can visualize how your designs are meant to be used, Solid Edge simulation can show you how they'll react. A combination of accuracy and efficiency, providing intuitive workflows being powered by a Siemens owned FEMAP and Nastran engine.
Yep. And so basically, the reason why I wanted to do that one is you may not get into the point where if you're doing 3D design to get into that, but it just, again, shows the art of the possibility of how, safe, whenever somebody designs something in 3D, how safe it's going to be. And then also letting the computer do the work for you. He talked about finding the optimal design. Well, based on certain parameters that you put into the computer itself, the computer and the software is going to find what is the best design for those inputs that you put into it. And that's just another example of why 3D. And this one, I like to use the word repurpose because we live in a world where we recycle, right? And we want to repurpose things. And that's what 3D CAD allows you to do. And with the technology that what we have come up with, Siemens has come up with, called Synchronous technology, think about this. This is a jack stand. Now, a jack stand, if you've ever had, your parents, your dad, or you've gone to, take your vehicle to the shop, they put them on, they elevate the vehicle so that somebody can work under it. And one of those ways is through a jack stand. You may even own a jack stand. Well, in this example, we wanted to give an example because it's something everybody can relate to, but it's like, okay, here's one design, but really I want to change that to this design. And how is that, how can I do that? Well, that's what this video is going to go through and show you, is just under 2 minutes, how you can take, any design, right? You can go out to the internet, you can pull down 3D models from anybody. And that's the great thing about Solid Edge, is it allows you to bring those in and, make it your own. And that's what this is. One way of being able to show this is to say, how can I repurpose this? How can I reuse this? And they're taking it, all to a different level, because they're actually changing the entire shape of what it once was. And to be able to do that easily and quickly is what we like to point out, right? So that is another way of just thinking about how you can use 3D CAD and how others use 3D CAD to make, in my mind, make life simple. So we started out with something that was rectangular or square, and then we just simply, with a few parameters, be able to make it into a round. And so it's very simple of how you can go through and change that. And this next video, go a little bit deeper into how we can do that. And again, I told you how you can go out and you can grab models off of the internet, off of GrabCAD or any other type of deal. All you got to do is do a Google search or anything on 3D models and download them, right? And so like on this one, we downloaded something, we've seen it, or we got it in from somebody else, or somebody else designed it. But we need to make some changes to it, or you want to make some changes to it to make it your own, right? To adapt it to what you want to be able to do. And again, it's just another way to show how 3D CAD enables you to go do this, right? And how easy and quickly it can be. And then once you make those changes, you can put them back into what I call, the Lego, right? The assembly, how you're placing things together. And in this case here, for those of us who are advanced, you may have a 3D model and a 2D drawing of that. Well, it'd be great if you could marry the two together, meaning that how can I bring information from a 2D drawing over and lay them on top of my 3D model? And companies do this all the time because they need accuracy. And so here we're just sitting there and we're placing that 2D information on top of that 3D, but now the dimensions are attached to that 3D and you're able to make those changes. And trust me, a designer from an engineer standpoint, this saves me a lot of time, right? And I'm not saying that everybody on the phone here today will be able to have this capability, but if you did, you could go in and make those changes very quickly, okay? And getting towards the end of our presentation, but I want to talk about another thing, why 3D? And social sharing is what I like to call this one. I wanted to put in the distancing in there, but I decided not to. But this is the ability to go in and you saw Doug talk about how we have an app to share things, but we also have a website, and this website is actually free for you. And we actually give you space. We give you 5 gigabytes of space to where, if you design something, then you can share it with your family, with your friends, or if you're doing a project for school, you can share it with your teacher. And so you can see here, you can just upload your designs to a website. And in that website, you're able to visually see the actual 3D model. You're able to explode things or cut through them to be able to see inside of what they look like. You can also, if you need to make some markups, if somebody wants to tell you some information, then you can do some markups in that and they can communicate back and forth to one another, comment on what those are. And it's just a great way to do this. We call it the Solid Edge Portal. And again, it's free for you to use if you want to go out there. And then the other one is things moving into the future. Now, some of us, have bought things off of Amazon, or we have bought things off of Wayfair, right? If you buy a piece of furniture, right, and you want to say, and there may be a button there that says view in your room, either in Best Buy or something like that, you can actually view it in your room. Well, that's called augmented reality. And that's actually taking a 3D model and viewing it in real space, okay? So here's a short video that talks about how you can do that, and with the capabilities with our CAD tool, you are able to do that.
Solid Edge Augmented Reality allows you to visualize your designs in a real-world environment, connecting the digital world with the physical world. The augmented reality journey starts in the Solid Edge portal, our cloud-native collaboration tool that can view any CAD data format and allows us to perform tasks like assembly explode, measurements, sections, or markups. Switching to the Solid Edge mobile viewer, which is supported on any iOS or Android phone or tablet, we can choose to view our design in augmented reality. Real-world surfaces are scanned, ready for model placement. The model is then seamlessly transferred from the portal to the physical setting and available for real-world interaction. You can easily visualize complex digital designs in a physical environment, walk through the model to understand the internal arrangements, analyze tight spaces to plan maintenance operations, or visualize how sub-assemblies fit with respect to off-the-shelf or catalog parts. View manipulation allows analysis of every corner of the model, whether it is piping, tubing, or complex wiring and harness routings. How about leveraging the augmented reality experience in an internal review or a customer meeting? Irrespective of the physical size of the product, models can be scaled to fit into the available space. Having a digital twin of your product in a meeting room allows in-depth discussions with relevant stakeholders or customers. Critical elements can be clearly visualized in the context of the entire product. Imagine the amount of time this could save between designer and shop floor interactions. Another way Solid Edge Augmented Reality can assist you is by virtualizing the look and feel of the product in its working environment, such as in this juicer example. By visualizing the form factor against other equipment, design decisions can be easily made, such as modifying the hardware specifications of this model to produce a more compact consumer juicer. Augmented reality with Solid Edge brings the digital and physical worlds together more easily than ever before.
So just showing you again what you can do with 3D design, and whenever you go to create something and stuff. And then this is probably one of my favorite parts of it is, it's great to see it in augmented reality, be able to show that to people, but to actually feel and touch your designs is one of the last why do this in 3D, right? And it goes down to 3D printing. And so I want to come to our next question because I'd like to hear from you. Do you have access to a 3D printer? Whether it be at home or at work, or maybe you have a friend, or maybe it's another one, right? Because we'll find out. We'll test your knowledge on what are some other areas where you can do 3D printing or get 3D printing. Okay, a lot of them it's other. That's interesting. All right, good deal. Okay, good. So a lot of them saying other. That's great. So let's take a look.
Solid Edge offers advanced additive manufacturing processes and tools to ensure 3D printed parts are created right the first time. Features from print bed orientation to physical thread creation make 3D printing with Solid Edge the perfect way to manufacture generatively designed parts like this bracket. Solid Edge's overhang check functionality allows users to visualize the amount of support material required to print a part, which is illustrated here in red. With a lot of support material needed, it would be better to print this part at a different orientation. With the reorientation tools, we can view the part in the context of the printer bed, where it can be moved, rotated, and even settled automatically. The new orientation reduces the support material required to print the part. A quick recheck using the overhang tool confirms this is a far better, more efficient orientation. Again, we can isolate the areas of overhang based on our maximum angle to get a clear picture of the support material needed. The wall thickness checker also allows users to visualize areas of the model that could present printing challenges based on printer specifications. Minimum wall thickness requirements can be defined to identify areas with potential issues. Isolating these issues gives a clearer picture as to whether the part will print successfully or need adjusting. Internal closed voids are another potential issue for 3D printing, particularly when using powder-based printing methods. Here we can see that placing a dynamic section through this part highlights a void inside the support. The Delete Voids command takes care of this automatically, removing the voids fast and easily. A common requirement on parts that have threaded features is to have the physical representation of threads, so that the 3D print is 100% accurate and functions correctly. Initially, when the threads are applied, they are created as cosmetic threads for performance reasons. However, these can quickly and easily be switched to physical threads as they are created. For models that already contain many cosmetic threads, Solid Edge can switch these to physical threads during the 3D printing preparation process. Features can be selected individually or as a whole and quickly converted to the matching physical thread. Final output of the 3D print file is a quick and simple process. Regular 3MF and STL formats are supported, and users have full control over the resolution of the output. From beginning to end, Solid Edge streamlines access to the additive manufacturing processes and tools needed to make your designs a reality, quickly and easily.
So just wanted to, give you an idea. You can print this out. You can send these out to a 3D printer. So our last question here is, where can you find access to a 3D printer? A lot of everyone said others, so it'd be interesting to see what your answer is on this one. Cool. So everybody knows about the public library. Yep. That's good to know. Awesome. Very good. Yes, so yes, all of them is where you can get access. But again, the Plano Public Library is a great place for you to get access to those 3D printers. Now, before we end our session here today, I do want to show you, especially for the young kids in our audience today, I want to show you an inspirational video of a young girl in high school and what she did with 3D CAD. Listen to Ashley's story.
I've always been an active person. I've always enjoyed the outdoors. When I was a little kid, the mountain was my playground. It's always going to be a passion for me. I was an infantry assaultman in the Marine Corps. I was shot in Afghanistan in 2012. Those injuries left me partially paralyzed, and I decided to electively amputate my leg.
I have a pretty heavy-duty foot. It allows me to be very active, but at the same time, it's a bit heavy.
Anything that requires more energy really just fatigues me faster.
I live in a nerd town. Huntsville is the hub of engineering in Alabama. We have so many new career tech programs like advanced manufacturing and engineering right in our high school.
Reset the clamp, a little bit tighter.
My brother started a school initiative for engineering, and he had a student who was really interested in doing some kind of biomedical project. Well, maybe she could redesign a lighter, more versatile foot.
So this is the mold, and we printed one of these. I'd always kind of wanted to be a doctor. When I discovered biomedical engineering, I was like, well, that's the perfect combination of medical and engineering. The whole foot together weighs 2.5 pounds. Ideally, we would like to get it within 1.7 pounds.
Yeah, that sounds great.
Once we got the prosthetic from Kendall, we had crazy ideas. We took the whole foot apart and modeled the original prosthetic in Siemens software. I'm just gonna draw 2 holes there real fast. Solid Edge lets me design and test the foot before we ever actually build it. We tell it a few things that we need, and then it takes all that information and it decides what's going to maximize the strength and minimize the weight to create a part that would be the lowest weight possible for Kendall. This has taken almost a year to the day. I don't think this has ever been done by a 17-year-old girl before. There you go.
Awesome. It feels strong, it feels sturdy. It does feel a lot lighter.
Nerds rule the world. Nerds got us to the moon. Nerds are doing things with prosthetics that I have never dreamed of doing. And go.
Having a lighter foot is going to open up possibilities that would not have been there before. You know, the more kids that can learn this stuff at earlier ages, they can go on to create new and better things that we're not even dreaming of right now. It's amazing.
In the future, I want to do the things that are impossible right now. If I can design this prosthetic now, I can't wait to see what I will design in the future.
So that's pretty cool to hear Ashley's story and what, you know, a young girl in high school was able to do and to help somebody out. And so as we come to the end of our session today, you know, I told you in the beginning, you know, we have the ability for you to get access to our CAD software, and we do it for free, okay? Because we want people to be able to expand, we want you to explore, and we want you to be like Ashley, to where, you know, you might be able to help somebody. You may be able to help a neighbor out and to design something. And so there's a couple of ways we've done this. One is through the Solid Edge community version. And this is mainly for makers and hobbyists, but this is a free version of our software that's available to you that you can do today. We also have a student version for educators and for students. Again, it's free of charge for you that you can go and you can download for there. And you might be asking yourself, okay, I can get the software, but how do I learn it? There's built-in tutorials, you know, to the software itself, but we also have websites where you can get resources and you can get tutorials, you can get classes, free classes that are available to you to go through things. Gear Up University is one of them, where you can see the different things that you can go and design. And again, you see the free resources for students, the free Solid Edge educational resources. Those are for teachers, but students can use them as well too, that you can do there. So Mike, I thought it was the last question, but I do have one more question for you, and that is, would you be interested in more classes on how to work with 3D CAD? Because we understand from you, do you want to learn more? Do you want to be able to do this? And so this will enable us to say, okay, how can we do this? How can the Plano Library and Siemens, you know, work together to help bring this to you? So it's looking like almost everybody is saying yes. And so what we can do with that is we can take that and we can work on how can we help you do this. And so as I come to the end of my presentation, again, I just want to thank you so much for taking the hour out of your Saturday and to come listening to me and to learn more about 3D CAD. And so I think, Kristen, I don't know, I think you've posted the links to those downloads that I've talked about.
It's actually going to be sent directly to the participants after the program. Yes.
Okay, perfect.
And they'll be posted on, we have a follow-up post on our blog, the library blog as well.
Excellent, excellent. I highly recommend you go download it and start using it, because it is, I've been doing this for 20 years and I've been working with CAD for more than 30 years. And so it's fun and it's exciting to see what people do and can do with it. So thank you for the opportunity to speak to you today.
Absolutely. Do we have any questions from participants? Would you like to put something in the chat that Kyle could clarify for you or answer questions? I don't see any questions right now, so just give him just a couple minutes here to put in a question, Kyle.
No worries. I get paid by the hour, so.
So at this point right now, the libraries are still not open to the public, but we do have 3 3D printers, and patrons are, have access to those to print their designs. And the cost for materials only for the printing is 20 cents per gram. So most projects that folks print at our libraries are maybe a couple of dollars to print.
Yeah, and that's a good point in that, the software will actually tell you how much it weighs, so how much material you're going to be using. So before you even go down to the library, you're able to understand how much it's going to cost.
Great. So I'm watching the chat and I don't see questions or a raised hand. We do have, for those who've joined us, we do have another Wonder Cafe coming up in July with a NASA ambassador about space and the night sky, what you can see in the night sky, constellations, comets, etc., how to find those things. And he'll be taking questions from kids and families about space and the sky. So hopefully you can join us for that, July 25th. I don't see other questions. Diana, am I correct? We're sending the links to the software out to participants in the follow-up email?
That is correct.
So you'll all be receiving those links that allow you to download the community version and the
Student version.
The student version, yes. Thank you.
Mm-hmm.
The NASA program will be posted on our community calendar, on the Plano virtual events calendar, as well as the library website. It's July the 25th. I believe it's 11 a.m. as well. And you'll have to register via Zoom the same way you did for today. And the link, it's not posted yet on the online calendar, but if you watch, it should be there in the next couple of weeks. At least by, first week of July, that link should be there. So we send out the list of programs that are coming in our e-newsletter, as well as putting them out on social media and on our website. So if you do not currently receive the e-newsletter that comes out on Thursday evenings, then you can sign up for that on our website under Learn, and then Engage with Us. And there's a place to sign up for the newsletter. We call it Check It Out. Thank you. Diana has posted a link to the calendar so you can see the upcoming programs. And then we have another Wonder Cafe coming in August with Verizon about sound, how sound travels. So we so much appreciate, Kyle, your time and your sharing your expertise. Obviously, you have a lot of experience creating a lot of really useful products and interesting designs. And I hope we've inspired some of our young people and even our older people out there to play with and explore computer-aided design and Solid Edge, and to try things out. We'd love to see you at the Plano libraries, at Plano Public Library, where you print some of your designs. You can start small, start simple. We'd love to print your designs for you when we open back up. And this is how you can reach us, find our information. And we very much appreciate your being with us today. And thank you so much, Kyle.
Thank you. I appreciate the opportunity.
Absolutely. Everyone have a wonderful day. Be safe. Enjoy the sunshine. And thank you so much. Keep learning with Plano Public Library. We love to see you. Thanks for coming.
Thank you.